Hi everyone, so I'm recording this lesson for the sake of people who are stuck at home because they have COVID and they missed the 2 lessons for this week. But I believe that everyone will also benefit from these videos because they can pause and rewind if they need to, because I realized that I actually teach very quickly for these few lessons. Okay, so in this chapter, what we are doing is we are looking again at ionic compounds and covalent substances. But this time, we are looking at how the bonding affects the physical properties. Okay, so in the previous chapter, we have learned to draw dot and cross diagrams to represent ionic bonding and covalent bonding. So in this chapter, we are going to look at how the structure and bonding in ionic compounds and covalent substances affects their physical properties, such as their melting and boiling point. Okay, so this video will cover ionic compounds. Next video will cover covalent substances, and there'll be one more video on chemical formula writing for ionic compounds. Okay, so without further ado, let's move on. Okay, so previously we have talked about ionic bonding, and we know that metals and non-metals, they combine together to form ionic compounds. Okay, so we will say that ionic compounds such as sodium chloride have what we call a giant crystal lattice structure. So lattice means that there is a certain pattern in which the cations and anions are arranged, as you can see from this diagram. And another term that we learned was that the ions are held by strong electrostatic forces of attraction. So electrostatic means that the positively charged sodium ion and the negatively charged chloride ion are going to attract each other. So similar to how a magnet, the different poles are going to attract each other. Okay, so this paragraph, you will need to memorize this because when you answer questions on this eventually, you will need to quote this paragraph. Okay, so now we're going to see how this structure of ionic compounds such as sodium chloride affects the physical property of ionic substances. Okay, first one, okay, they have a high melting and boiling point. Okay, this is because the strong electrostatic forces of attraction between the ions will require a large amount of energy to overcome. And in fact, this is a very common question to be asked in tests and exams. So, for example, the question will ask you, explain why sodium chloride has a high melting and boiling point. And this question is usually worth 2 marks. Okay? So, you can use this acronym of SAFE to answer this question. So, you're going to say, sodium chloride has a giant crystal lattice structure. So, first part of the answer, you're going to tell me what is the structure of sodium chloride. Next, you're going to explain the bonding in sodium chloride. Okay, so there are strong electrostatic forces of attraction between ions. So AF stands for attractive forces. And finally, E stands for energy. So you're going to rationalize to say that the forces of attraction will require a large amount of energy to overcome. And therefore, sodium chloride has a high melting and boiling point. Okay, so the next property is that ionic compounds are hard but brittle. Okay, so if you look at this paragraph here, I didn't break it up into 2 parts, and I will work on this next time. But essentially, there are actually 2 explanations here. Okay, so hardness refers to the ability of a substance or a material to not get scratched. Okay, so ionic compounds, crystals are actually hard. They are they're not easy to scratch because usually the ions are held in fixed positions by the electrostatic forces of attraction. Therefore, it is very difficult to overcome these forces to move the ions. So we will say that the electrostatic forces will cause the ions to resist motion. They cannot move. But if you eventually apply enough force, okay, the ions are going to move away from their position, and this will cause ions of the same charge to touch or to contact each other. Okay, so when the ions of the same charge come into contact with each other, they are going to repel because they have similar charge. And these forces of repulsion between similarly charged ions will actually become stronger than the forces of attraction between oppositely charged ions. And when this happens, the lattice structure is going to break apart. So therefore, if you drop an ionic crystal onto the floor, it's going to break into many pieces due to this. Okay, so this diagram is on your notes. It's going to explain why. So you can see that the pink circles represent sodium ions, positively charged. The green circles represent chloride ions, negatively charged. So at first you can see the lattice structure where sodium ions and chloride ions are actually alternating. Then when you apply a force, the ions move out of their positions and the sodium ions will touch another sodium ion. The chloride ion is going to touch another chloride ion. And the lattice structure will break apart due to this repulsion. Okay. And finally, we have two more physical properties to go. The first one is just for your knowledge, there is no explanation required, which is that ionic compounds are usually soluble in water, but insoluble in organic solvents such as alcohol. Okay, and finally, the last physical property is about electrical conductivity. Okay, so in the solid state, okay, ionic compounds are actually poor conductors of electricity. But when we melt the ionic compound, or when we dissolve the ionic compound in water, so in other words, in the molten or in the aqueous states, they become good conductors of electricity. Why? Because in the solid state, the ions cannot move. Okay, so electrical current, for a current to be produced, we need charged particles such as electrons or ions to be able to move to complete what we call an electrical circuit. Okay, so when the ionic compound is in the solid state, the ions are in the fixed positions, as we have mentioned, so they cannot move. And when they cannot move, there are no particles to carry electrical charges from one end to another. But when we melt the ionic compound, or when we dissolve it in water, now we have overcome the ionic bonding, the electrostatic forces of attraction. The ions can move, and they can carry the electrical charges from one end to another. So therefore, in the molten state, in the liquid state, or in the molten or liquid state, and in the aqueous state, the ionic compound is a good conductor of electricity. Okay. So now I want you to try exercise 2 on page 78 of your notes. So please pause the video for 10 minutes and try, okay? So you need to get used to the way of writing these answers. And you're also going to notice that these sort of questions were actually very frequently combined with chemical bonding, dot and cross diagrams. Why? Because in the previous syllabus, these two chapters were actually the same chapter, so this new syllabus actually just broke them up. So they very frequently appear side by side. Okay, so please pause the video for about 10 minutes, try this question, and then after 10 minutes, come back, resume the video, and we will go through the answers. Okay? Okay, so I'm going to assume that you have actually tried the questions, and we're now going to look at the answers to this question. Okay, so first one is to draw dot and cross to represent the bonding in calcium chloride, CaCl2. Okay, so we have talked a bit about ionic dot and cross, so I'm not going to spend the time to go through all the steps again. So to take note that common errors, okay, so if you drew your calcium ion with cross, then your chloride ion should be drawn in dots and vice versa. Secondly, question will mention whether valence electrons only or not. If it didn't mention, then you have to draw all the electrons to show the full electronic configuration of both ions, okay? For those who are concerned about the chemical formula, don't worry, there'll be another video on this soon, okay? So, next part, okay? Explain in terms of structure and bonding why calcium chloride has a high melting and boiling point. Okay, so to answer this question, as I have mentioned, you're going to use the SAFE structure to answer. Okay, so S, calcium chloride has a giant crystal lattice structure. So you tell me the structure of calcium chloride solid. Then you tell me the bonding or the attractive forces between the ions. So the ions are held by strong electrostatic forces of attraction. And finally, you rationalize this, use this to explain the amount of energy needed. So because the forces are strong, they require a large amount of energy to overcome, and therefore calcium chloride will have a high melting and boiling point. Next, calcium chloride crystals, why are they hard and brittle? Okay, so this is the longest explanation. There are actually 2 full paragraphs to mention. Okay, so first, why are they hard? Okay, because the ions are held in fixed positions by strong electrostatic forces of attraction, and they resist motion, which means that they will try not to move from their fixed positions even if you try to apply a force. Okay, however, if you apply enough force, they become brittle, so that means they break easily, because if you apply enough force, the ions will move away from their fixed positions, and the oppositely charged ions will come into contact with each other, and this causes there to be a force of repulsion between the same charged ions. Okay, and this is actually stronger than the force of attraction between oppositely charged ions, and this will cause the ionic lattice structure to break apart. Okay, I know it's long, I know it takes time to memorize, but you need to start now before WA2. Okay, last question is about electroconductivity. So what physical states do you expect calcium chloride to conduct electricity? Okay, so there are 2 physical states in which calcium chloride can conduct electricity, which is the molten or liquid, as well as the aqueous state. Okay, so aqueous state just means that the crystal, the ionic compound, has been dissolved in water. Why? Okay, second part is to explain your answer, so why? Okay, because you need to tell me that in both the molten and the aqueous states, the compound will have free moving ions that can carry electrical charges from one end to another. Okay, so with that, I'm going to end off this video. The next video will be on structure and bonding for covalent substances. Okay, so thank you for your time.